So here's a quick review of what we did last time. So we're doing transformation of random variables. And in that transformation of random variables, so this is a quick review or summary. So we were talking about y being a function of the random variable x through this function g of x. So capital Y is a random variable, x is a random variable. That function of random variable gives you another random variable. And given the PDF on x, you're interested in finding the PDF on y. And we only talked about monotonically increasing functions, right? So for monotonically increasing function, because they're monotones, they're one-on-one, right? So the inverse so the inverse is unique. Okay, so the conclusion we had. So I'm not going to go through the proof again, of course. The conclusion we had was that fy of y as a function of the PDF on x is equal to fx of x times dx divided by dy evaluated where evaluated at y equals g inverse of x, right? And this g inverse of x is unique. So and that's because of the fact that the function is one to one. Okay. And another form that we did was this was also equal to fx of x divided by dy by dx evaluated at y equals g inverse of x, right? So these were the two forms that we looked at, and there were some examples that we did as well. Okay, what we're going to do next is so we've talked about monotonically increasing functions. Now we're going to talk about monotonically decreasing functions, and then we're going to generalize it to non-monotonic functions. Okay, so for to functions which are not necessarily monotonic. Okay, so this is section number 3. So section number 3 is monotonically decreasing functions. And I am going to go over this rather quickly because the ideas are very, very similar. So I'm not going to go too much into the details, nor the proofs, right? So we once again have y equals g of x. And if they are monotonically decreasing, that also means that the function is one-to-one, right? So given y, there will always exist a unique x, which is the root of that particular y. Okay? And that's because of the fact that monotonically decreasing है, तो one-to-one भी होना चाहिए system function. Okay? So this is, for example, what g of x may look like, right? So this is x, and this is y equals g of x. Right? And the way I go about evaluating the PDF of y is once again through that mapping of intervals or through that CDF approach that we looked at, which was that let me try to find, first of all, fy of y, which is the probability that the random variable capital Y is less than or equal to small y, which is the probability that g of x is less than or equal to y, right? And from here, I can map this probability, which is actually on the probability or the event, which is on a function of x, to an event which is on x itself, right? So can somebody help me here? Okay, for the case when this function is monotonically decreasing, what does this event map to? Anybody? So what does this event map to in terms of an event on x? Gmaz?
It will be x is greater than equal to g inverse of y.
Right? So this is x is greater than equal to g inverse of y, and g inverse of y is unique, right? So that's a given. That's implicit here. Okay, and it should be quite clear. Well, y equals ax plus b wali bhi example humne ki thi where a was negative. Then because of the fact that a was negative, or because of the fact the function was decreasing, that's why the equality has to flip, right? Graphically, अगर आप देखना चाहें, तो you see कि this is some particular y, and for here, this This is x equals g inverse of y, right? So this is what you're looking at, right? Which is x is greater than equal to g inverse of y, right? Um, so so this is equal to probability that x is greater than equal to g inverse of y, and then what do I do? So this is a CDF on x, right? So this is actually, sorry, this is 1 minus the CDF on x evaluated at g inverse of y, right? So this is what the PDF of y is, right? In order, sorry, the CDF of y is. In order to get to the PDF, what do? I differentiate both sides with respect to y, and that gives me this conclusion. This is fy of y. This is equal to minus fx of x times, and I'm slightly skipping a step here. This is x equals g inverse of y. Right? The ideas are exactly similar to what we did before, except that you have a negative sign involved, right? That's the only difference. That's the only difference, okay? And a little bit more thought reveals that this must be therefore equal to minus fx of x divided by dy by dx evaluated at x equals g inverse of y, right? So pretty much the same ideas as before, except that you have this minus sign here, right? And this minus sign here when the function is monotonically decreasing. Okay? Acha. It turns out that the transformation for both monotonically increasing as well as for monotonically decreasing functions, or the relationship is of the same functional form. We can transform it into the same functional form, just like we did it for y equals ax plus b example. ठीक है? मैं इसको किसी तरीके से एक ऐसी फंक्शनल फॉर्म में लिख सकता हूँ ट्रांसफॉर्मेशन को, such that is applicable not only to monotonically increasing functions but also to monotonically decreasing functions as well. What would that generalization be? Can I write that generalization? You see, this thing up here in blue, this thing here up in blue, and this thing up here down here in white, they look pretty much the same, right? Except that there's a minus sign here, that there's a minus sign here. ठीक है? इसको मैं यूनिफाई कैसे करूं दोनों को? जी शोएब.
If you put a modulus on both of them, then they will both be equal.
Right. So why a modulus? So that's, can you try to explain that? Okay.
So so if you put modulus, फिर ये negative sign भी अंदर होगा, it will become positive, and and that will be equal to the one we have derived earlier.
Okay. Right. So the key here is that if the function is monotonically decreasing, the slopes are negative. Right? So dx by dy is negative as well as dy by dx because the function is decreasing. Okay? Monotonically decreasing, the slope always stays negative. Okay? And if it stays negative, so I can have the minus sign inside the, so this minus times the slope becomes positive afterwards. Okay? So the generalization I can come up with therefore is that if x of x is equal to f, sorry, says f y of y is equal to fx of x times dx by dy modulus. Okay? And evaluated where? Evaluated, and this is evaluated at x equals g inverse.
Sir, I had a question.
Yes, go ahead.
Could you scroll up to the review part that we did at the start of the class?
Yeah.
There we evaluated at y equals g inverse of x. So I was.
Sorry. That's not right. That's not right. Sorry.
Oh, okay.
So ultimately, this has to be a function of y, right? So this is x equals g inverse of y, and this is x equals g inverse of y. Right? Thank you. ठीक है, ये पहले भी बता देता हूँ मुझे. All right. So, and this is equal to fx of x divided by dy by dx modulo, right? And this thing needs to be evaluated where? Evaluated at x equals g inverse of y, right? And these forms are applicable um, to functions, any monotonic function, right? Regardless of whether that monotonic function is increasing or decreasing, this is going to be applicable. Because this relationship is going to be applicable. Okay? Why? Because if it's monotonically increasing, I know the slope is positive here, so that doesn't really the modular doesn't make any difference, right? And I know if the slope is decreasing, in other words, the function is monotonically decreasing, the slope is negative, right? And if the slope is negative, the modulo makes it positive, and it should have been positive. Why? Because this was a minus sign here. Okay? So in both cases, this is consistent. G Mohsin, you had a question?
नहीं सर हो गया सही.
Okay, see. All right. Okay. Now, what's coming up interestingly next is what do you do if the function is not a monotone? Right? If the function is not a monotone, it is not necessarily one-to-one. Okay? It is not one-to-one. So you'll be able to find some y's for which there are multiple roots. Okay? The question is, how do we deal with that kind of a scenario? So this is now, so what we're going to do next is the most general form that you can imagine, right? So you had monotonically increasing functions, then we had monotonically decreasing functions, and then we generalize that all together in this expression here, in this expression here, which is now applicable to, so this is applicable to any monotone, regardless of whether it's increasing or decreasing. Okay? Now we want to go a step further and see what is going to happen if the function is not necessarily a monotone, right? So this is section 4. This is non-monotonic functions. Okay. So let me, for non-monotonic functions, let me start with a toy example, if you will, or a toy problem, if you will. Okay. And that toy example is perhaps the simplest thing you can think of in terms of a non-monotone function. So a toy example is y equals x squared, right? So this is, of course, we know this is not a monotonic function, right? So what does it look like? This is the function, right? So you have x here and you have y here, right? And why is it not a monotone? I mean, because for greater than 0, it's an increasing function. For x is less than 0, it's a decreasing function. And that means that the roots are not unique, right? So the function is not one-to-one. So in other words, for a given y, there is not a unique root to that, right? So for a given y, in this particular case, there are two x's that could have resulted in that y. Okay? And the way I'm going to go about this is to follow an intuitive approach first, without using any relationships, without using any formulas, right? Just to give you an idea of mapping of events, right? And then we're going to generalize it to to a formula, if you will, okay, which is actually going to be a generalization of this equation, right? This equation here, okay? So given any PDF on X, right, and you're required to find the PDF on Y, कुछ पहला step बताएं कोई. What do I do? Like I need to find a PDF on X, PDF on Y as a function of the PDF on X. What do I do? जी गाजी क्या ख्याल है?
आप इसको रीजन्स के अंदर डिवाइड कर ले और इंडिविजुअली ट्रीट कर ले.
रीजन्स के अंदर डिवाइड कर लें. व्हाट डू यू मीन बाय दैट?
मतलब लेफ्ट साइड पे वो डिक्रीज कर रहा है, राइट साइड पे इंक्रीज कर रहा है.
Okay. Okay. So I would, so that may be an approach जो कि आप आगे आगे थोड़ा सा जा रहे हैं, अगर जो जनरलाइजेशन हम करेंगे वो ये करेंगे. But I would rather just follow the direct CDF approach, right? And which is कि जी, let me try to find the CDF on Y. So Fy of Y is just the probability that the random variable capital Y is less than or equal to small y, right? Which is the probability that x squared is less than or equal to y, right? Now, all I need to do is to map this event x squared is less than or equal to y into an event on x itself, right? So I want to see कि यार ये जो event है x squared is less than or equal to y. What does this event map to in terms of some intervals on x? So when is x squared is less than or equal to y? When is that? When does that happen? Ghazi? So when is x squared is less than y?
आप ये कह रहे हैं कि अंडर रूट लेना आपको x के टर्म्स के अंदर चाहिए.
Yeah, so मुझे ये चाहिए x की terms में चाहिए मुझे. Yes, exactly.
आप बस अंडर रूट ले लेंगे, लेकिन आपके पास दो वैल्यूज आएंगी x
Yes.
की.
ठीक है, तो एक प्लस रूट वाई आएगी, एक माइनस रूट वाई आएगी, right? So I say कि जी when x squared is less than or equal to y, whenever minus root y is less than or equal to x is less than or equal to plus root y. Right? So I can see कि अगर ये y है तो this is minus root y, this is plus root y. ये कब होता है? ये कब होता है? जब ये चीज होती है, right? Capital Y is less than or equal to small y whenever capital X is in between minus root y and plus root y. And whenever capital X is between minus root y and plus root y, capital Y is between 0 and y. ठीक है? Which is capital Y is less than y. Capital Y is less than small y. ठीक है? So there's a correspondence between these two events, right? And therefore, because there's a correspondence between these two events, the probability is going to stay the same. So this must be equal to the probability that minus root y is less than equal to capital X is less than equal to plus root y, right? What is this probability equal to? क्यों मोहसिन? In terms of the CDF of X, can I write this probability in terms of the CDF on X? जी, Shoaib, go ahead.
PDF.
So capital F evaluated at under root y minus capital F evaluated at minus under root y.
All right. Right, so this is what capital Fy of y is. And my job, of course, is to find the PDF. In order to find the PDF, I'm going to differentiate both sides with respect to y. And what do I get? On the left-hand side, I get the PDF on y. What do I get on the right-hand side? Right-hand side, if I differentiate this, Ali, क्या मिलेगा मुझे? PDF तो मिलेगी, लेकिन फिर बस सिर्फ PD मिलेगी।
into under root y.
Y into under root y. Right, so it's going to be actually the derivative of root y. Okay, what is the derivative of root y?
1 over square root 2y.
1 over 2 times root y. Right, so this is fx evaluated at root y. And then what? And then there's a minus sign here, and then this is minus 1 upon 2 root y times fx evaluated at minus root y. Right, so I've skipped steps here. These are simple algebraic stuff, calculus steps, because sort of derivative in and this turns out that this you'll get this result. So 1 upon 2 root y times fx evaluated at root y plus fx evaluated at root y minus root y. Right, so this is the solution. Okay, now this was all good. This was, I mean, conceptually very, very nice. But the problem here is, what if I gave you a function which had 4 roots, or which had 10 roots, or which had 20 roots? Right, we have to have some sort of generalization or some sort of general relationship which we can go ahead and apply to any monotonic function that we come across. Now, this monotonic function was a nice function, not too bad. Okay, and let's us look at things very, very intuitively. However, if there's a more complex looking, there's a more sophisticated looking non-monotonic function. Okay, जिसमें बहुत सारे roots exist करते हैं. We have to have a generalization, and that is what we're going to talk about next. And then we're going to see कि जी जो भी generalization आएगी हमारे पास. So what we've done up here with the toy example, that formula is going to be applicable here as well. We're going to see we're going to get the same results in both cases. Okay, so here's a generalization. So let's, if I give you a function, let's say this is some function, this function of x. Here this is, so this is capital Y, and this is what the function looks like. Right, some nasty looking function. Okay, and then there's this some small y here. Right, now how many roots does this small y have? जी आसिफ, कितने रूट्स हैं इसके? Mohammed Asif, can you hear me? Okay, जी Mohsin, go ahead. 4 roots हैं, right? So I'd see कि यार ये y पे I say कि how many x's could have resulted in this particular y? There are 4 such x's. ठीक है? There's this thing here which is x1. There's this root here which is x2. There's this root here which is x3, and there's this root here which is x4. ठीक है? जी Ali, go ahead. Question? Ali, question आपका?
No sir, वो आंसर करना था.
अच्छा, okay. Right. Now,
How are you defining roots?
Roots?
Aren't roots the
Roots का
point?
मतलब ये है कि जी for this particular y, what are the x's that could have resulted in this particular y?
They would vary depending on what y we choose.
Of course, of course. ठीक है, so I'm not assuming any functional form as of yet. Right, I just look at the curve and see कि उसके roots कहाँ पे exist करते हैं. Right? जी ईशा, go ahead.
So sir, basically you're saying that this is limited in its domain on X and isn't a continuous function?
Yeah, so this is just an illustrative example. Okay?
Okay.
This is an illustrative example and अब ये assume कि जी इससे आगे और आगे पीछे कोई नहीं exist करता है. तो बाकी सब जगह वो zero map कर देता है. या कुछ और कर देता है. I don't care. Right? It's just an illustration. Right? अच्छा. अब what is important here is कि if I wish, I can go ahead and follow the same sort of CDF approach that we did in the monotonic functions, where we said, KG, let me first of all try to find the CDF on Y, and then I'm going to differentiate it, and I'm going to get the PDF on Y, right? Instead, I'm rather going to work directly with the PDFs here because that makes my life a little bit easier, right? And I will have some hand waving involved, and a mathematician may have problems with that, but engineers should be okay, right? So here's what I'm going to do. Let me assume KR, there's another Y, which is some small distance away from it, which is Y, small y plus dy. ठीक है? तो small y कहीं था और y plus dy के ऊपर I'm finding the roots again, right? So and then I see कि यार ये कहाँ पे इसके roots exist करते हैं. And I see कि यार ये एक है, right? This is x1 plus some dx1, right? This here is x2 plus some dx2, where in this case, of course, dx2 is going to be negative, right? Because the function is decreasing, right? And this dx1 and dx2, by the way, are going to be different. Why? Because, and they're going to be a function of what, by the way? क्या किस चीज़ का function होगा, गाजी?
dy का?
नहीं, so dy का तो है, लेकिन how big or how small dx1 or dx2 is depends on something, and that something is a slope of the function. I mean, whether the function is increasing slowly or rapidly, right? That is going to affect how big or small this dx1 or dx2 is. Okay? And in this case, dx2 is in fact negative, and that indicates that the function is actually function is decreasing around x2. Okay? Similarly, this is x3 plus dx3. In this case, dx3 is going to be positive, and this is x4 plus dx4, and dx4 is going to be negative in this case. Okay? Acha. And the reason why I did all of this is because now let me just try to find the probability, and that probability on y I'm going to find on an interval, right? So I'm going to say, what is the probability that the random variable capital Y is in between small y and small y plus dy, right? ये किसके बराबर है? That's what I'm interested in finding, right? And once again, this is going to be mapping of events, right? When is capital Y, when does capital Y reside on this interval? Or in other words, what interval does X have to lie in so that capital Y is going to reside here in this interval? So what do you think? Ji Mohsen?
So general form में between x and x plus dx.
नहीं, लेकिन जनरल फॉर्म अभी मैं तो आपको रूट्स दे रहा हूँ ना, राइट? सो आई मीन व्हाट इज x?
सर कोई भी x1 और x1 plus dx1 के दरम्यान में या फिर between x2 plus dx2
Okay, so
and x2 के दरम्यान.
there's an or element there, right? Which is actually which points to some sort of a So Maz, do you want to say something?
सर वो यूनियन ऑफ इवेंट्स वाली चीज आ जाएगी.
Yes. So
Yeah.
that point, which points to unions. Okay. And that, and what I mean by that is capital Y is going to be on this white interval if and only if X is either here or here or here or here. Okay. So when capital X is in either one of these four intervals, that would mean that capital Y is in this interval here, right? And if capital Y is in this interval here, that would mean that capital X is in either one of those four intervals. So there's a one-on-one mapping between these events, right? So I can say, therefore, that this is the probability that X1 is less than capital X is less than, so let me dx1, right? So this is one event union with x2 plus dx2 is less than x is less than x2, union with x3 is less than capital X is less than x3 plus dx3, and that union with x4 plus dx4 is less than capital X is less than x4, and then this closes off the bracket. Okay, so it's a union of is the probability that X lies in either one of these four intervals, right? Now I can generalize this, right? How do I generalize this? So let's say, I mean, this was an illustrative example in which I said, yeah, there are only four roots, but they could have many roots. Okay. In general, let x1, x2, xn be the roots corresponding to y. And let x plus be the set of roots around which the function is increasing, and let x minus be the set of roots around which the function is decreasing. Okay, so the generalization I can make is that the probability that small y is less than capital Y is less than equal to small y plus dy. This is equal to the probability of union xi belonging to x plus, and this is, so for all of those cases in which the function is increasing, I have the root appearing first, and the plus dx part appearing second. Okay, and then this union with another union, which is xi belonging to x minus xi plus dxi is less than capital X is less than xi. Okay. So I'm going to stop here for a while and let you ask any questions that you may have. Hanji. Any questions here? Right. So all I've done is just some generalization. I've split up the roots into two sets. Right. For the first set contains all of the roots around which the slope of the function is positive, and the second set is a set of all roots around which the slope of the function is negative, right? So the function is decreasing there. Because those are the two sets, right? And around, so jahan pe negative है slope, wahan pe dx of course is negative because the function is decreasing. Okay? So therefore, for all of those values, this appears here. Okay? Ji Isha.
Sir, as per my understanding, when you began the example, you were taking into account one pair of coordinates which we are observing in these intervals, right?
One pair of coordinates, what do you mean by that? Pair of coordinates?
Like when you're talking about that point lying in that interval,
Yeah.
that's a pair, like that's one set of x and y. So now I am beginning to think that we can perhaps take this for multiple coordinates as well, multiple points as well.
नहीं, multiple points से क्या मुराद है आपकी? So y एक ही है. So there's only one y. Right? There's only one y, but there are many x's that could result in that y. Right? अब बोलें. Right? So when you say multiple,
Yeah, that y is only one. That y is also only one.
yes, the y is only one. But
Right. So yes. So y is only one. I get that, but what I mean to ask is that when we're computing this probability, we are taking some x and y जिसको हम देख रहे हैं कि वो इस interval में lie कर रहा है या नहीं.
not some
Right.
y. There's only one y. Okay? And we're saying what does that small y correspond to in terms of the intervals of an x? I know as far as the x-axis is concerned, there are many roots, or there's xi's that could have resulted in that particular y. Okay, so you see there's we says these are the roots. These are the roots which are corresponding to a particular y, right? And these are going to change when you change y. So these roots are a function of that small y.
So isn't it that we have to take a reference point to actually check all of these things?
What do you mean by reference point?
Like some coordinate on that very curve to see if it is even lying within that y plus dy range or not.
No. So if the roots, I mean, there's going to be at least one root, right? Or there may be no roots. For that case, so you have the null set, and that's the probability, therefore, of that particular y is going to be 0. Okay, so it's all about a mapping of events. You say, Kitty, what x's could have resulted in this small y, right? And since we're now talking about an interval on the y-axis, so we have an interval on the y-axis, okay? And we're just saying, Kitty, what values x could have taken for capital Y to take values within this interval. And that's all we're doing. And we're exhausting all of those intervals on the x-axis that could have resulted in this, in y being in this interval on the y-axis. You get the point?
Okay, but it's a little hard to see it when x would be extended into infinity.
So there would be infinite roots then. There could be infinite roots.
Yes,
infinite roots, okay. If I give you y equals sine x.
Right? Sir, I get that, but then how would we actually compute the probability for an x which is going till infinity?
Homework problem for that.
Okay.
Right, so you just have to, अभी देखें ना union बड़ी आसानी से एक और चीज में बदल जाएगा, which you can easily handle.
Okay.
right? So probability of unions is what? Now, here's where the little bit of hand waving is going to come in. And I'm going to say that the events are mutually exclusive, right? So therefore, I can say, yeah, this is equal to a summation over xi belonging to the set x plus, and this is probability that xi is less than capital X is less than equal to xi plus dxi plus summation xi belonging to x minus, and this is probability xi plus dxi is less than capital X is less than xi. Right? In going from here to here, what have I assumed?
They don't overlap.
They don't overlap, which basically means they are
Like,
mutually exclusive. And is that true?
not always.
Not always. Unless unless dy is very, very small. Right? So if dy is very, very small, and that's ultimately we're going to work with the limits. When dy is very, very small, these intervals indeed are going to be mutually exclusive. There's going to be no overlap because the intervals are very, very small. And the intervals are very, very small. The roots are unique, so they don't overlap. Okay? So that's why I said a mathematician may have problems with this, an engineer will not. And that's the kind of hand waving that I was talking about, right? So I've gone from the equation above to the equation below by assuming that the interval lengths are very, very small, because of which I can assume that these intervals are mutually exclusive, ठीक है? Or these events are mutually exclusive, sorry. ठीक है? किसी का हाथ यहाँ पे खड़ा हुआ था जी ईशा.
So, sir, basically meaning that dy would be very small would be relative to the gradient of the curve at different points?
Yeah.
Because if there are sharp jumps, then
So we're
dy
not dealing with, so we're not
will
dealing
have
with
to be very, very, very small.
शार्प जंप से बहुत ज्यादा फर्क नहीं पड़ेगा, लेकिन जब स्लोप जीरो हो जाएगी तब मसला पड़ जाएगा आपको.
All right. Okay.
Right?
Yes.
Right. So I'm assuming the slopes are not zero. Okay. So then I say, okay, once again, assuming that dy is small, dx's will be small as well. And what can I write this probability as approximately when dy is small? Can I write this as a function of the PDF when dy is small? G Salar, can I write this as a function of the PDF approximately when dy is small? G Maz.
सर PDF of y evaluated at y multiplied by dy जो उनका interval का size है.
Why? Because it's the area under the curve, right? So the probability is the area under the curve. So if I'm integrating from y to y plus dy, and since dy is so small, the PDF can be assumed to stay constant within that small interval. Okay, so then the area under the curve is just simply the height of the PDF multiplied by the length of the interval. Okay, approximately, right? And that's once again the hand waving thing that I'm going to use here. And similarly, I can say, and what about the probability that xi is less than x is less than equal to xi plus dxi. This is just simply fx evaluated at xi times dxi. Okay? And what about this probability? The probability that xi plus dxi is less than x is less than xi. ये किसके बराबर होगी? Shoaib, what will this be equal to?
The same thing जो करें लेकिन माइनस आ जाएगा क्योंकि आप लिमिट्स चेंज करते हैं इंटीग्रल की तो माइनस आ जाएगा.
Good, right? So this is dxi and it has to have a negative sign here. And another way you can justify that it has to have a negative sign is because dxi, remember, is negative for all of those cases, and the probability can never be negative. So the only way the probability can be positive is if you have a negative sign in front of dx. Okay. Now, armed with these three expressions, I can try to come up with this relatively more simpler form, which is times dy is actually equal to summation xi belonging to x plus, and this is fx evaluated at xi times dxi plus xi belonging to x minus fx of xi times minus dxi. Right? And I can take the dy there on the other side. So this is times divided by dy. This is dy here. And then I can replace everything with an absolute value, right? So I claim that this is actually equal to xi x plus fx of xi dxi by dy plus xi belonging to x minus fx of xi dxi by dy. Is this correct? Kyun Salman, what do you think? Is this okay?
Yes, sir. I think it's okay.
Why is it okay?
So because we are taking the modulus for the negative side, but we're just looking at from the other side. We're not changing.
I mean, why? So again, I mean, why can I say that this is equal to the modulus? Is the modulus of x equal to x?
The
Mohsen.
modulus can be x and minus x.
It can be x or minus x, right? But then if it can be x and minus x, so then what I wrote must not be true. How do you take care of the negative part? I mean, what if dxi by dy was negative? तो फिर तो एब्सोल्यूट लेने से वो नेगेटिव साइन खत्म हो जाना था. दैट मींस द इक्वेशन above is not the same as the equation below. So what's the catch here? जी मोहसिन.
सर जो x प्लस वाला सेट आप कंसीडर कर रहे हैं उसमें स्लोप्स तो हमेशा पॉजिटिव होंगी और जो x माइनस वाला आप सेट कंसीडर कर रहे हैं उसमें हमेशा नेगेटिव होंगी. तो एब्सोल्यूट वैल्यू शुड वर्क.
Right, excellent. So that's why I split them up into two sets in the first place, right? Okay, all of the roots in this set are characterized by the fact that the slopes here are going to be positive, and all of the roots which are in here in this set are characterized by the fact that the slopes evaluated at those points are going to be negative. And therefore, I can replace this with an absolute value here, knowing the fact that this is always going to be positive. And here I can replace it with an absolute value here once again, knowing the fact that the slopes are always going to be negative. So if the slopes are always going to be negative, so minus x is equal to absolute of x when x is negative. Okay? Remember that fact, right? So you know all that fact. Okay? So this allows me to write this in a very, very nice, if you will, I mean, it's a general form, and say कि this x summation is actually over all the roots, right? And this is fx of xi evaluated at dxi by dy, absolute. And with a little bit more analysis, you can actually show that this is also equal to xi over fx of xi divided by dy by dxi, right? Where ये क्या है? This is a set of all roots corresponding to y. ठीक है? Right. So this is our conclusion, right? So this is that relationship that I said that you were going to try to derive. This is that generic relationship. Okay. Now, we can apply this if you want. So let's try to apply this for the y equals x squared problem, right? So, अच्छा, by the way, अगर ये is this applicable to monotonic functions? Shaila, do you think this is applicable to monotonic functions?
Applicable होगा.
How?
उसके अंदर हमारे एक रूट आ जाएगी ना, तो हमारा xi.
Excellent. So this is applicable to monotonic functions. So this is the most general of forms that you can think of, right? So and this is applicable to monotonic functions as well, because monotones there's only going to be one root, and the summation that I have is just going to be over one root only. Okay? But in cases where you have more than one root, this is that generalization, right? So this is the most general of formulas, if you will, that we'd consider when transforming a random variable through a function relationship. ठीक है?
सर अगर कांस्टेंट होगा हमारे पास फंक्शन, कैसे अप्लाई करेंगे फॉर्मूला?
Okay, excellent point, Qazi. So this is there's a disclaimer here that this is applicable only to the case where there are countably infinite, up to a countably infinite number of roots. If the roots are uncountably infinite, this is not applicable. ठीक है? और जो आप केस पे कह रहे हैं ना कि जहाँ पे कांस्टेंट है, वहां पे रूट्स आर अनकाउंटेबली इनफाइनाइट, and we'll talk about that example there. ठीक है? So remind me again, अभी थोड़ी देर में एग्जांपल एक बात करते हैं, right? अच्छा, so let me write this note down here. Right. So this is applicable when the number of roots are countably infinite, up to, right? Not applicable to uncountably infinite roots. Okay. So example later. So let's do a simpler example first. And let's just try to apply that formula, if you will, right? And when this once again is y equals x squared. Right? So we say कि for given y, there are two roots. Plus root y. So x1 equals plus root y and x2 equals minus root y. Right? And if I just directly apply the formula, right? So what do I have to do? So here this is going to be fx of x divided by dy by dx absolute. And where do I need to evaluate the slope? I need to evaluate the slope at x1 equals plus root y, right? So that's the first root. And this is the second root. This is x equals fx of x divided by dy by dx evaluated where at x equals minus root y. This is where the second root is. Okay? So what do I get? So this is fx of root y. What is dy by dx? Chana, let me not skip those steps here. So this is fx of x, dy by dx is 2x. And x equals root y plus fx of x and dy by dx once again is 2x absolute here, and x has to be minus root y, right? And this is therefore 1 upon 2 root y fx of root y plus 1 upon 2 root y fx minus root y. Right? Is everything okay, or did I miss something out, or there's a catch here? I mean, there's something I've actually missed out. And that is okay. All of this needs to be, so what happens if y is negative? जी नाज़िन अगर y negative होता तो फिर
There is no x for negative y.
Exactly. So if y was negative, there would have been no x that could have resulted in that y. Okay. So when when I say this for a given y, there are two roots, x1 equals plus root y and x2 equals minus root y. This is applicable only when y is greater than 0, right? Or equal to 0. But when y is less than 0, there are no roots there. Okay. And in that case, the PDF is going to turn out to be equal to 0. Because there are no roots, you're not doing any summation, that's actually the null set. So that PDF is going to turn out to be 0. So essentially what we have is all of this is actually multiplied by u of y, right? So all of this is multiplied by u of y. So this is u of y. Right, and which just caters to the fact that y cannot be negative. Okay, y has to be positive, right? And that makes sense because if you have a random variable which can take on either negative or positive values, both of them together, and if you're just computing the energy, y equals x squared, so the squared value, that squared value or y, that new random variable y can never be negative. It can only take on positive values or non-negative values, right? So as an example, so if fx of x was 1 upon root 2 pi sigma squared e raised to power minus x squared by 2 sigma squared, right? So the x was actually a Gaussian random variable which is zero mean and has a variance sigma squared, and then you had some sort of squaring law, ठीक है? ये so basically essentially आपके पास एक noise आई है, noise term आई है जिसको आप square कर देते हैं, right? और square करना पड़ता है कभी कभार क्योंकि when you want to compute the energy of anything you would square that anything, right? And when you square that anything, you're interested in what is the outcome, how is that randomly distributed? So if the input was Gaussian, what is the squared Gaussian look like, right? And this relationship now that we have above is going to allow us to compute the PDF of that Gaussian random variable squared, right? And the example that the answer that we're going to get exactly is going to be this 1 upon the fi of y is going to be 1 upon 2 times root y 1 upon root 2 pi sigma squared, and this is going to be what? This is going to be e raised to power minus y divided by 2 sigma squared plus 1 upon 2 root y times 1 upon root 2 pi sigma squared and e raised to power the same thing minus y upon 2 sigma squared times u of I, right? And I mean, you see both terms are exactly the same. So therefore the answer that you get is 1 upon root 2 pi y sigma squared e raised to power minus y by 2 sigma squared u of I, right? So this is the PDF of a squared Gaussian. Is this a Gaussian random variable, by the way? Can this be a Gaussian random variable? I mean, this is of course not a Gaussian random variable, right? Why is it not a Gaussian random variable? This does not have a Gaussian form, and the biggest giveaway is the fact that this is non-negative, right? A Gaussian random variable is both positive as well as negative. Okay? So it's just a simple application of the relationship that we derived above, and we can have many more examples. Many more examples are there in the textbook solved examples, and we're going to see some in the homework problems as well, right? And if you wish, we can conduct some tutorials for those examples as well. Ji Mohsin.
You could just scroll down just a little bit. It's being covered by.
Oh, okay. Okay. Is that okay?
Yes, sir.
Right. Any questions before I give you an example जो कि थोड़ा सा गाजी की comment से derived है? No questions? Right. So let's consider this function. Y equals g of x, and this is plus 1 if x is greater than or equal to 0 and is equal to minus 1 if x is less than 0. Okay? Which is actually nothing but the sine function, by the way, right? So this is equal to sine of x, right? You have a random variable which is an input, right? And you're just determining कि sine इसका क्या होगा. Okay? So it's like an LED which lights on if the sign bit is positive and if this turns off if this is negative. Okay? So it's plus 1 or minus 1. Okay? And given, so let's say if x is Gaussian, 0 mean, and some variance sigma squared, determine the PDF of X. Okay. Should we go ahead and apply that formula that we derived above? क्यों गाजी?
सर वो कांस्टेंट वाली केस नहीं आ गया?
बिल्कुल वही आ गया,
ग्राफ बन गया,
राइट? सो बिल्कुल कांस्टेंट वाला केस आ गया, इसलिए जो फॉर्मूला है दैट would be we would be misguided to try to apply that formula and trying to find the roots, right? The first thing is, what does the function look like, by the way? Asif, what do you think the function looks like?
It's a sine wave होगी.
Sine wave होगी. Salar, what do you think?
सर x की पॉजिटिव वैल्यू के लिए +1 होगा और x
Yeah.
की नेगेटिव वैल्यू के लिए -1.
Right. So this is function. Right. So हम इसको signum function भी कहते हैं. Right. So this is -1 here and this is +1 here. Right. So for all values of x which are non-negative are mapped to y equals +1. All values of x which are negative are mapped to y equals -1. Okay. Now, if you were to go ahead and try to apply that formula, you would say capital Y equals +1 pe let me try to find the roots, right? How many roots do you have? You have an infinite number of roots, but not only that, you have an uncountably infinite number of roots. Okay, so that summation does not really make sense. वहाँ पे कुछ ना कुछ really असल में if you थोड़ा सा और करें तो that should be replaced with an integral. But we should not go there. The answer to this is much simpler than the application of that formula. Right? So the point I want to make here is that be mindful of when you can apply that formula and when you can do some simple tricks to come up with an answer in a much simpler fashion. Right? So इसका आंसर क्या होगा जी शोएब?
लेकिन शायद वही आंसर सर जिस तरह हम वो सिग्नल्स में फूरियर ट्रांसफॉर्म करते थे कि हम फॉर इंस्टेंस for ease हम for instance t का Fourier transform कैलकुलेट कर लेते थे और कांस्टेंट पा जाता था, तो यहाँ पे भी यही कर सकते हैं. ये जो है ये डेरिवेटिव है ऑफ t for x greater than 0 and derivative of -t for t less than 0.
Okay. Like so Shoaib, this is I mean अगर आप इस तरफ जाते हैं तो this is going to make your life very hard. I mean there's a much simpler solution here. जी गाजी?
तो इसका बस वो इंट्यूटिव आंसर नहीं है. x greater than 0 0.5 है, x less than 0 0.5 है.
Yeah,
why? So y 1 की प्रोबेबिलिटी
बिल्कुल सही आंसर है, लेकिन क्यों?
क्योंकि वो Gaussian random variable है. Yeah,
so basic so Moaz, do you want to say something? Your answer is perfectly correct, Ghazi. Lekin let's see Moaz, what Moaz has to say.
तो वही मैं ये कहना चाह रहा था कि x greater than 0 के लिए हम वो f of PDF of x से फाइंड कर सकते हैं ना, PDF of y मतलब.
Yeah.
So what kind of multiply कर.
So what kind of a random variable do you expect capital Y to be? I mean, is that going to be a Gaussian random variable? Is that going to be a continuous random variable? Is that going to be a discrete random variable? Ji Nazish?
Discrete random variable can take either +1 or -1 or
yes, so it's going to
PDF may convert.
This is going to be a Bernoulli random variable, right? So I know that the output, which is y, can only take on two values, which is either +1 or -1. So all I need to do is to determine what the probability of y equals +1 is, and I need to determine what the probability of y equals -1 is, right? So the probability that capital Y equals +1 is actually the probability that capital X is greater than or equal to 0, because y equals 1 maps to x is greater than or equal to 0. Okay, that's a very simple answer. So, which is half, because it's Gaussian is symmetric around 0, mean 0 hai, to mean ke around hamesha symmetric hota hai Gaussian, right? And similarly, what is the probability that y equals -1? This is the probability that x is less than 0, and this is half as well, right? So you have a PMF, right? So you basically y is a random variable which is discrete and is characterized by a PMF. can you describe its PDF as well? Giuseppe, you because you answered this on the discussion forum. I'm not sure if people are following up on the discussion forums. The answer to this was on that. Giuseppe?
Sir, the PDF of this.
Yes.
Sir, so I was a bit confused, but then you said that if we can just derive this CDF of the function, then we can get the PDF of that too. So
good. So go ahead and do it. So chalo main kar deta hu yahan pe. So what do you think the CDF is going to be? So this is f y of y, okay, and this is y. Mohsen, if I can draw the CDF first.
Sure, sir, sure.
ठीक है. So ये 0 है, ठीक है. -1 पे क्या होता है? -1 पे ये हाफ हो जाती है CDF. हुज़ैफा?
yes.
+1 पे क्या होता है?
1 हो जाएगा और फिर
1 हो जाता है and stays 1. So what is the derivative of this?
So there's going to be two impulses at
exactly
-1 and +1.
Exactly. और उनकी heights क्या होंगी?
Half and half.
Yes. So you see this height is half. And this height is half as well. So if I differentiate this, I am going to have an impulse of height half at -1, and I'm going to have an impulse of height half at +1 as well. Okay? So if I go by that derivative relationship, so this is half delta y plus 1 plus half delta y minus 1, right? So the PDF of discrete random variables can be specified in terms of the unit impulses. Okay? और I mean the simplest thing is कि यार जहाँ जहाँ वो PMF reside करती है ना, उस mass को just replace it with an impulse which has a height equal to that mass function height. ठीक है? Mohsen, do you have the same answer or कुछ और सोच रहे थे आप? ये screen मेरी pause हो गई.
expression देना था.
Yeah, good. So मेरी screen pause हो गई for some reason, and maybe that's a good time to stop as well. So sharing बंद हो गया. So I had another example. So let me skip that. Am I online? So let me not skip that. So let me leave that as a problem here, and then we'll come back and try to do it next time. So another example I leave for you as an exercise and see if you can try to do it next time. Or exercise. And this exercise is that y equals g of x. And the function definition is what? The function definition is that y equals x if x is greater than or equal to 0 and is 0 otherwise. Okay? Determine fy of y as a function of fx of x. Right? And what kind of a function is this, by the way? I mean, this is a half-wave rectifier. Right? Just a half-wave rectifier. All you're saying is that all the negative values are actually mapped to 0. I mean, they cut off, and all positive values are passed through. They stay the same. Okay?